Hello, myself Dr. Chittaranjan Mondal, Department of BSH, and Swami Vivekananda Institute of Science and Technology. Today I am going to discuss one example, 1 or 2 for examples of triple integrals. Okay. See one example, 0 to a, 0 to x, 0 to y, x cube, y square, z, dz, dx, dz, dy, dx. This is our example. So in this problem, whenever we try to integrate in the three dimensional on 3 dimension, so here 0 to a is a constant, 0 to x, 0 to y. Okay. So 0 to x means integration 0 to 1 minute. Integration 0 to x, obviously this is a function of x. Means whenever we integrate and put the upper limit and lower limit, and we get the function of x. This is the function of x. Again, this is 0 to y is a function of y. And last, this one 0 to a is the constant. So it is obvious we cannot integrate first with respect to y or with respect to x. So we have to first integrate. So 0 to a. So how to integrate first? So 0 to x and 0 to y, x cube, y square, z. First we have to integrate, then with respect to z, and after then with respect to x. With respect to y, because this is the function of y. So in the next integration we can integrate with respect to y and then dx. So integrate this 0 to a, 0 to x. If we integrate with respect to z, we can get x cube, y square, z square by 2, 0 to y, dy dx. After then 0 to a, so if we, that is 0 to x, so that is x cube, y square, that is y to the power 4 by 2, dy dx. Again we integrate with respect to y. If we integrate with respect to y, 0 to a, we can get x cube, y to the power 5 by 10, 0 to x dx. Next one, 0 to a, if we, that is x to the power 8, x to the power 8 by 10 dx. Again we integrate simple one dimensional integration, x to the power 9 by 90, 0 to a, that is a to the power 90 by a to the power 9 by 90. This is one example. Another example, if we try to solve another example here, another example, let us have a new page. Another example, evaluate x square plus y square plus z square dx, dy, dz, where V is the volume of the cube bounded by the coordinate planes and the planes x equals to a, y equals to a, z equals to a. So in this problem it is given the limit, the volume of the cube bounded by the coordinate planes and the planes x equal to a, y equals to a, z equals to a. Volume of the cube. First we draw the cube here. This is x axis, y axis, z axis. So this portion xy plane, xz plane and yz plane. This portion, this is origin, this one the origin, this is a 0 this is 0 a, this is 0 a. Sorry, this one 0 a 0. So obviously this one, this point a, and this point value coordinate of this point 0 a this point a 0 a and this one a 0. So I think it is clear the limit of the integration 0 to a, all are here 0 to maximum length of x, 0 to a, length of 0 to a, 0 to a. So that's why the limit 0 to a, 0 to a, 0 to a, and x square plus y square plus z square, because integration as all are constant, so we integrate with respect to either with respect to x, either with respect to y, either with respect to z, whatever. So dx, dy, dz. So now we first integrate with respect to x. So that is 0 to a. If we integrate with respect to x and put the limit, so obviously a cube by 3 plus y square plus z square a dy dz. Okay, again with respect to, if we integrate with respect to y, 0 to a, if we integrate with respect to y, so then we can get a to the power 4 by 3 plus a to the power 4 by 3 plus a square z, I think. You can check y, only y. So a to the power 4 by 3, y cube by 3. So a here, so a to the power 4 by 3 plus this one. So that is 0 to a, 2a to the power 4 by 3 plus a square z dz. So again integrate with respect to z, and we can get 2a to the power 5 by 3 plus z here, z square by 2, a to the power 4 by 2. This is the result. Next, let us check the answer. Some mistake here. Oh, sorry, z square here. Z square. So a to the power 5. So 3. So So that is e to the power 30. So in this topic today we discussed two examples with two different examples, and the next class we are going to discuss on the triple integration but different topic. Okay, thank you.